Hello, my name is Michael Weber. I am a second-year master's student at the University of Minnesota Duluth, and I'm going to be presenting a project that we've been working on in developing a pressure measuring garment to understand the effects of compression on the human body, specifically for the treatment of autism. And with that, we'll get right into it. So to set the stage, 1 in 59 children by the age of 8 years old are diagnosed with autism. So common tendencies with someone suffering from autism is easily excited or frightened by loud noises, hand flapping, eye poking, bouncing up and down in their chair, troubles focusing are the most common ones. So there have been several studies that have shown deep pressure stimulation, such as compression, can lead to a decrease in these tendencies. However, there's limited research into how much pressure is necessary to reduce these tendencies, as well if we apply certain pressure at certain areas of the body, will this reduce certain tendencies over other ones? That's where our research team came in, and we wanted to develop a sensor to measure the pressure at certain locations on the body, and this is what we came up with. So our principal element for this sensor is a stitch sensor made out of conductive thread, which is illustrated here on the left. So we used a 2-needle bottom cover thread stitch. So our blue and red thread here is non-conductive thread, and our green is conductive thread. So as this sensor, or as this stitch is being stretched, the resistance changes. So we can actually get a relationship between that and the displacement for the sleeve when it's placed on someone's arm and relate that to pressure. So we placed one of these stitch sensors at the wrist, the elbow, and the upper bicep. Each one of these was connected to a voltage divider circuit, which was measuring, or which then we can measure the resistance from using an Arduino lily pad. So going into the participant and mannequin trials, we had 4 participants for this study. We had 2 participants wear an extra small shirt and 2 participants wear an extra medium-sized compression shirt. So each participant completed 3 trials of at least 1 minute wearing the shirt for a total of 12 trials. We also had a mannequin arm, which was made out of a harder rubber material. It also completed 3 trials wearing the medium-sized shirt for a total of 1 minute for each trial. So getting into the results, in table 1, we have the circumference at the wrist, elbow, and upper bicep for each one of the participants, including the mannequin arm. And then table 2, we have the average pressure values for each one of these locations for each one of the participants. So there are several patterns that we can notice. So one trend that we saw was between participants 1 and 2, participant 2 had a larger circumference at their wrist, and we saw a positive correlation with that in the pressure values measured for each participant. However, for those same participants, the circumference at their elbows was the same, but the pressure values at their elbows were quite different. And this is most likely to, as the elbow is bent or flexed, the area around the elbow changes quite dramatically, and this can change the pressure values measured there. So another thing we noticed is participants 3 and 4. Participant 4 had higher or larger circumference around their elbow and bicep. However, participant 3 had much larger pressure values at both those locations compared to participant 4 and compared to any other participant. And this is most likely due to the conductive thread for the elbow and the bicep crossing at some point and connecting, which is going to increase our resistance, which is going to increase our pressure values. So in summary, we were able to develop a relationship between resistance and displacement. And from there, we were able to get a pressure value from the resistance of each one of these stitch sensors. There was large variability in our participant trials, and this is most likely due to changing an area of the elbow and grounding of the circuits, fatiguing of the actual fabric itself. So in the future, we need to find a more consistent way to alleviate these problems. And with that, that's the end of the presentation, and me and my team thank you for listening.